Okay, hello. Just checking latency a bit. I should be on soon. Okay, hey, so welcome to the weekend workshop number 12, and we are gonna speak about DirectX 11 plugins today. So let's get started right away. So the first thing to do really, if you want to do that a little bit properly, we need to bit prepare, because Visual Studio is kinda, well, dynamic plugins are not super ideal for DX11 plugin, and Visual Studio as raw setup is not ideal either. So okay, I see a little quiet. Let me check microphone again. And, oops, that's on mute. Recording. Okay, that will be a little higher. Right. So the first thing we're gonna do actually is we need to prepare projects a bit properly, because Visual Studio is a bit messy by default. So it's quite good to start with a bit of starter. So let's have a look. So what I've done here, I copied all the dependencies that we need. So that's all the 4v dependencies, and that's the DirectX dependencies. There's a version for 64 bits and 32 bits here. And so we have this solution here, and we have those targets. So if we look at the solution file now, here, so we have empty folder nodes, empty folder lib, and we have those targets here. So this one is references, so it's it contains every reference around. So instead of adding that again and again, we just have it once and for all. And we have a bit of build setup, like for defending if we want to do debug or release builds. It's always handy to have this, and we have a default output path. So we just set up some form of defaults here. Like we allow unsafe blocks everywhere, because really we use unsafe code most of the time in DX11. So it makes no sense to enable it all the time. So now, like, I'll create a simple project. What I've done, I'll put it in the material after, but there's a project template. So if I do add a new project, so you can see here there's a template for DX11 node. So I'll just call it weekend workshop, and we'll put it into the nodes folder. So we wait a little bit. Sometimes Visual Studio is a bit slow. Okay, and now you can see you already have all the references we need. And if we just gonna unload project here, edit, you can see we already import all the right targets, and we already have the unique ID. We have the output path, which will go into node plugin. So we have a pretty much ready to go setup instead of having to deal with instead of having to deal with all these references again, like we just have this project template and everything is up and running right away. So it's a bit of a good thing to well, gain time. And if we need to change something, we can just go change the target and it can update for all the projects. So I'll just change something here to just create a specific folder on the output path and reload that project again. Like if we wanted to create a project from nothing, we would have to do this add new project, like C# class library, and nodes, and we would have to go change. We would have to go unload or add the reference, but it's adding the reference is a bit of a problem because you have the 32 bits and the 64 bits. So it's a bit of an issue as well. So we would have to unload like this and unload. So just copy it. And yeah, we would have to copy this here. Pretty much copy this around. And remove all these conditions. That's all the default which is set by Visual Studio, and it's not really good when you want to maintain projects properly. So it's much better to use this project to prepare projects templates. So okay, I'll just unsave all this and reload all. Okay, yes, and we'll delete that because we won't need it. And another thing which is quite useful, because we'll want to start debugging pressing the start button, so I'll start to use a lib folder, and I'll create a new project which is actually just an empty project, so I'll call it like debug starter, and we'll put it on to the lib folder here. So it's just a stupid empty project, so I'll just delete. It has actually completely nothing in there. We are not interested by anything except we want to set it as startup project, and we go to properties, like debug start external program, and you can put your 4v path. So like here I go here, so here I got my 4v path now for 64 bits, and if I press start, it's starting on my other monitor. Okay, it's here. But it's basically starting 4v and will start to load all the debug for the other project. So instead of messing up with the nodes, it's quite nice to just have a simple project here just to set up the debug system. And let's reorganize a bit. That will go here. And that is not always needed. So now we have a bit of like a nice setup ready to go. Now if we go Shift F5, we can stop debugging. So now we got a bit of a proper setup and we're ready to go to start to really write code. But it's always, before to start to write different nodes, it's always quite nice to be able to have a bit of better organized projects. It saves time in the long term. So now let's start. We're gonna start by something quite simple, and we're gonna have the standard classic like that. We're gonna start to write a dynamic buffer, and we're gonna use our custom structure. So I'll create a folder called buffers, and we need to add a new class. and we'll call it. We're gonna create a buffer which contains which contains, let's say, 2 color, and yeah, 2 color will do. Okay, so we'll call it a dual color structured buffer node and add. And now we are using it's a dynamic, so we need the using, so using so we'll just create the base template first. So and now we said we wanted 2 colors, so we're gonna create a simple struct. And we need to also make sure we set up the layout, which in our case is very simple. And normally it should be done. Yeah, that's not right. And we need the standard plugin info. So name info. And well, that's all the standard metadata. And we need 2 inputs, so we said color 1. I'm sorry, it's a dynamic array buffer here. So now, now we have this dual color, so we have our 2 inputs here, and we have our array buffer here. If we check on quick actions, and sometimes it's a bit slow. Okay, so it's protected override build buffer. And now it's not color 4, it's dual color. Yeah. So we just need to build so we have the array which will contain our buffer before it's copied on the card, and we have how many elements we need to copy. So now we can compile. And now we have our dynamic buffer, which has a different structure. So if we press start now, we will still need, okay, I'll wait for vv to be started. Okay, now the problem is, of course, we don't have our dynamic buffer here yet, because we need to set up the node list. So here, so if we have our project here, solution file, everything is built into this deploy debug 64, and you have the packs folder here. So we obviously need to put this pack folder into the node list here. Which I'll add here. Pack, not sorry, that's not exact folder name. Okay, simple. And it's still not here. It's too annoying about that. Okay, and let's start it again. And we have our dynamic buffer color dual now here. So if you want to double check it, whatever. And here, so now we can use our structured buffer. So if I check now and say I want the second color, I get the second color. And if I want the first color, I get the first color, obviously. So it's very simple to use this to create those custom dynamic buffer nodes. and it's generally reasonably useful, like to be able to pack a bit more data together instead of using, like you can use like a mix of bit, you can pack bit everything you need to render an object in there, and and then you can just grab it using the instance ID in general. So it's like very easy because you already get a template for you already done. So I will save this. Okay, so now we've done this first little sample. So now we're gonna do something a bit different. We're gonna try to build a custom geometry. So first thing, we'll create a new. So you can either create new folders like geometry here, or you can create a new node template. So it really depends how you want to organize different files. So you can have a lot of little projects, or you can have like one project which contains a lot. It's totally up to you. Like I have no problem with either. So now let's start. We're gonna build a custom geometry node. So create a new class. And what we're gonna build is a simple circle. So we're gonna decide to build a geometry which draws a line. So circle line node. So public, and we're gonna this time build it from scratch. So okay. So if we get on the quick action here, like we just allow Visual Studio to implement interface for us. So we start here. So we're gonna keep that one reasonably simple. So the idea is to build a geometry, and we want to build indexed geometry. So our circle, what we'll want is we just want a simple resolution pin, and we'll only build one circle. We won't make it spreadable. It's just for example. So first we need to input. We want a resolution, and we'll set a default value equals, let's say, 8, and min value equals 2. Max, we don't care about max value, and we need a high diff spread in that case of int resolution, and we need to output a resource. So this one I will make sure to write it from scratch. So I will not use a template for it, so just in order to see a bit what's involved in general. So there are different templates for geometry which are already made for you, but in that case we'll try to build something straight from scratch. So now we need an output, which is going to be our geometry. And so first it needs to be a DX11 resource, so which is this template here, and we want a geometry. And it's and actually we said we want it indexed, which in that case actually makes kinda no sense, but never mind. So let's actually I'll do so here and geometry output. So the wrapper on DX resource means because we can have several devices asking for the same resource. So we wrap this around to say, by the way, I can hold this resource, but for several devices, which are the render context provided to you here. So like, unlike normal plugins, like which call evaluate once per frame, in DX11 or DX9, actually it's the same concept. Like several devices can eventually ask for the same resource if you have several renderers, which means update might be called several times. So DX11 holds a dictionary. So the first thing we need to say here is we're gonna say, okay, we need to say invalidate equals to false, which will means we need to rebuild the geometry, and we'll say here invalidate if resolution that is changed invalidate equals true, and we'll also want and that needs dispose as well. And we need to delete the resource because we need to create a new one. So if geometry output 0 is not null, geometry output 0 dot dispose. And the very important thing is we need to we just need to initialize. So here I'll just summarize a bit again from the beginning. So first we want to initialize our geometry output here, and we say if the resolution is changed, we need to build a new one, and we are destroying the old one if it's around. So now actually this we also need it on dispose, because what we want is if the node is deleted, we want to destroy the resources as well, and we want it also on destroy here. So now the most important part, as you guessed, is to build this update method, which, as I said, can be called several times per device. So what we'll first do is if we need a new one, or we don't have this resource in that context yet. And here is the most fun bit. We need to create our geometry. So yeah, I see the question is on destroy context specific. That's actually right. It's context. Yeah. So sorry. So now back into it. So now we need to create this DX11 indexed geometry. So what we'll do is first we'll check what's in there. So F12, and so we have what we have called a drawer, but it provides a default. We have an index buffer, which contains the indices. We have a vertex buffer, which contains vertices. We have vertex size, vertices count. We have like a helper static, which is create from. So it will grab vertices, indices, and layouts. So that's what we will use to help for the create. We can assign a new drawer, and we can lock buffers if we use dynamic geometry. We have the draw method, and bind method assigns to a pipeline. And but so in our case here, we just want to create it, so we will use this static helper here. So we have a render. We need to provide the render context, which is provided by us. We need to pass an array of vertices, we need to pass an array of indices, and we need to pass a list of input elements. So in our case, because we use a line, as we said, we will pass position and UV. So we want an array of cos 3. So let's just imp. So here. So there are already some templates for there's already some template structure for what we need here. So that's position 2. We'll use position 3 texture 2 vertex here. So that means we'll have a 3D vector as position and the 2D vector as texture coordinate. Even if we don't use the whole data, it's reasonably handy for the input assembler. So we'll just stick on that for now. So we need an array of this. And we need resolution 0. And we need a list. So we're gonna calculate the vertices first, which is a simple circle formula. So let's actually save this. List equals resolution 0 and equals 0 by res I plus okay. And let's do something. Yeah, and we'll probably also need Okay, and so vertices. And we'll just use okay, so here oops, yes, right. So here we just built our vertex list, which is just a bunch of circles. And we need to build an index buffer, which in our cases it's raise for now. So we just use this, each index is the same basically. So we created a circle vertices and we created a list of indices. We'll see why we use those indices a little later. So now we need to create this geometry. So DX11 indexed geometry equals dot create from, and it's pos3 text to vertex context, that's vertices, and indices, and for the input layout we can get it from here. And now we obviously need to assign it to our context. So geometry output 0 context equal, and it's by 2 v. And the last thing we need here is, because here we have a new, it's already destroyed here, so we should be sorted for a little bit. So we're gonna start for v, and we're gonna see how it looks like. So what's kind of cool now also is you can obviously put breakpoints here. So for example, for now it's not loaded, for v is not loaded yet. But now if I start to type circle, geometry lines, and constant effect, we will see it will look total junk. So save circle. So there's a few things we are still missing here. Okay, and I'm not ultimately used to Visual Studio 15 because obviously their debugger decided not to work. Configuration, debug, it's okay. We will probably also want a 64-bit build in here. Okay. Now we can see the location here is correct. And now we can also see it on the debug. Okay, now we can see our geometry working, but we have obviously a little problem is we are for now rendering triangles. So whereas we want a topology of line lists in our case. So geometry in out and topology line strip and enabled. So now we have a line strip, and if I do a uniform scale, we can still see a little problem is our circle is not closed. So we have two things. Our topology is not right, but we don't want to use that node here, and we can see our node is not closed, and that's why where the indexed geometry goes in. So we're gonna close that again and go back here. So first we said our topology is line strip, so we're gonna set it here directly equals topology.line strip. And we said we need to close our little circle, but we're not gonna create a new vertex, we're just gonna reuse one because the first vertex is 0. So we need to loop, which means instead we need one more vertex to display. So we add 1 to the list of indices, and indices res equal. So what we do is instead of creating a new post3 texture, which costs you a lot of, well, obviously in that case it's a bit insignificant, but if your geometry is larger it becomes more important. Instead of creating a new vertex, we just create, because we already contain it, we create a new one. So we just reuse the first one. So to loop, we use the first index here. We reuse the first vertex at the end of the list. So if we now recompile and start again, and if we reopen our little circle example, now we can see our date circle is closed. So you can obviously add different type of parameters to it, but that's here for the basic. So we'll just see how to use the indices a bit more in depth. We're gonna create a second geometry. So by the way, for people watching, if it's too fast or too slow, just don't. I'm watching the little chat window also, so just don't hesitate to comment. So now we're gonna do another geometry again, and we're gonna create a little wire box out of lines. So we're just gonna create add class box line node. And we're just gonna copy paste all that float here. We don't need and remove resolution. So actually in this case we'll have actually pretty much 0 parameters, so it's just one output once. That's it. And we just get rid of all that again. Okay, so in that case, actually our resolution, everything is fixed. So we don't need this and we don't need this here. We just create it once and that's it, really. So now we have a box with lines, which means we don't care about normal and duplicate the face. So we have obviously 8 vertices. I will keep text code, just, well, actually, let's do it vector 3 directly like that. And and so now our indices are gonna be segment, which means we have 4 segments for the front face, we have 4 segments from the back face, and we have 4 segments to do the join between the front of the back, because some of them are already done, which means that's 4 by 2, 8 plus 8, 16, so we have 24 segments. Actually, we don't have pos 3 vertex, it's a bit unfortunate. Okay, we'll use pos 4 then. And we'll use a vector 4. So the first thing we need to do here is to create the vertices. So it's a bit rebarbative in that case. We'll copy that later. So we have our bottom left here. Now we do bottom right. And now we want top left and top now we can copy those here. And we need, actually, that's a bit, yeah, I kinda mixed up front and back, but never mind. It really depends on all the. So now we have our 8 cube vertices here, and we need to join them together. So we bottom left, bottom right, we need to connect bottom left to top left. We need to connect two, sorry, so one bottom right to top right, and so we did bottom left to bottom right to top right. We need bottom left to top left, which is 0, 2, and we need bottom right to top right. No, I did that one already. Top right to top left. Okay. And in our case here, we need topology line list. So we're gonna do the back face, so bottom left, bottom right, 4, 5. Bottom left, top left, 4, 6. Bottom right, top right, 5, 7. Top right, top left, 6. Oops, and I'm mixing up that. Okay, so we can already check actually if it's working. Okay, and we need a new patch for that, so constant. We don't need texture, so we use constant no texture technique here. And box geometry line, I'll just save the patch. Box line. And we'll want a camera. We can so there's 2 things we can see. It's not totally ready yet because we still have lines going to 0. So we still need to finish the connections, but we can at least start to see a bit of the work in progress. So So let's connect the last 4. Oops, yeah. I don't know how to count today. Okay, so now we need to connect bottom left, so 0 and 4. Bottom right, 1, 5, 2, 6, 3, 11. Okay, give a little time to start up. And now we have a little issue again. Yes. By the way, you're not always forced to use debug, so if you want to start quickly, it's also possible. Yeah. There we go. Okay, and now we have our nice box with lines. So that's how we create geometries. So you can see different ways to prepare them, and they are done like directly. Now now we're gonna check something a little different again. We're gonna just create actually a simple render state. So one of the little thing with render state is it can be a little costly, as you can see here. And so group we're gonna take a constant. So blend depth stands here, and we'll want no depth, and we'll want a rasterizer of no curl simple, and we want blend here. Okay, so that's actually extremely simple blend. But you can see blends are a bit costly all the time because they use enums, they have to check if enum changed. So actually this one is a bit of a preset we use all the time. So we use blend with blend, no depth stands here, and rasterizer to no curve, simple. So what we'll do is we're gonna just build a blend state as a node which contains all those three, no need for enum or anything. So we're gonna build this as a minimal thing. So we'll call it alpha blend node. Actually, this one, the point is it's alpha blend, and we want our element to be completely static, as you seen in the sample. If I open it again, actually we don't want to ever change this value. We just want to set up something like which is gonna be always the same. So the first thing actually we need is we'll want to actually implement this interface instead, which is called once on creation. So evaluate will be called every frame, but we will have nothing to do in there. And the only thing we want is we need an output render state and protected. So in case of render states, they're a bit specific, so because they use these hash keys, so actually they are not tied to a device. So if we go to a render DX11 render state, state out. So we can see actually we have here, instead of using on render state, instead of using like the state in the device, we use descriptors and we ask the device to get one for us. So we need to provide blend, depth stencil, rasterizer. Please note that now also reference and blend factors are also part of the state. And so now we just need to say DX11 render state equals new, and we need equals. So we have presets held in here. So we have the same key as per the enum counterpart. So depth stencil equals DX11 depth stencil states dot instance dot get state. No depth and rasterizer equals and it's no curve simple. Okay. And we just need to assign it once. So this dot state out 0 equals state. So about plugin evaluate mandatory. The problem is, yes, it is mandatory because the node scan will look for nodes that implement this interface. So yes, it is mandatory. So even if you do nothing in there, you must still add this interface, otherwise it will not appear in the node list as the 4v SDK is designed now. So yes. So now let's close that and rebuild. And if we open our blend test again, and we call now alpha blend. So now we have a node that exactly does the same thing, except of course it's kind of faster because it doesn't have to deal with all this enum thing. So it does pretty much nothing because data is already contained. So and it's also a bit more compact, so you don't, if you need this state quite several times, you could do a little module for it, of course, but you can see doing it as a plugin is also much faster, and it's a bit more compact too, so it's quite easy to do a bit of presets for blend states like that. But actually what we will do now is we actually gonna want to go like to do another blend state, because that was using just preset, which is just half the fun. We're gonna create actually our own blend state. So actually what we will want, actually we want to kind of what we call reverse the blend. So instead of using the alpha here, when we do the standard alpha blend, we use, like in the second group element, the blend operation is done using this alpha, which is here. And now we're gonna want to reverse that. So what we want is to perform the alpha blending, but we want to use this alpha from the source, not from the destination. So we can use obviously a blend run the state advanced, but we'll do it inside the plugin. So we'll create a new alpha blend which is called reverse. So we'll just copy that one and we'll call it target blend node. So now the idea is pretty much exactly the same on our state, but we will want to use the alpha on, which is currently on the render target, instead of the alpha which is in the new output. So we can't use these presets anymore because there's no preset for it. So we just gonna need to create it ourselves. So blend description, blend state, and DX11 PSD equal new blend state. And we want that one here in state. So now we need to go inside those, so we don't need this setting. We want no independent blend, and hello. Render targets. Okay, and sometimes IntelliSense is still not really good on here, so we'll have to get that. Okay, and now we need to set up our state. So we need to enable blending. So true. Blend operation is also add. Blend operation alpha is also add. What we want is we want to preserve the alpha, so that one equals 0. We want to write everywhere. And now we need to say destination blend is basically how much you want of the existing render target. Which means we want the destination blend to be blend inverse destination. So basically, when we use these blends here for color, what we do is, instead of saying we want to use the alpha from the new texture, we want to use the alpha which is already for now in the render target. So if I check that one now, and okay. I'll save it as something else also. Nope. Target blend. No, it's probably needs to save. And it's completely decided to ignore my node. So now we assign this one here, and we can see now our alpha is designed by the render target. Okay, so obviously if you need, because obviously it's quite vast, so there's a lot of different examples around. So yeah, one thing of course is to you obviously have if you need quite a lot of examples also, you obviously have the whole GitHub, which I know is a bit daunting to look at, but it just shows a bit what to what we can do around. So you have actually quite tons. Well, pretty much every node is here and shows exactly what's needed. So yeah, you can also look quite. There's quite a lot of obviously examples in here. So now let's see what's the ID. I'm checking on time. Okay, it's not too bad. So now we'll just do something a bit different again. Okay, I'm gonna show quickly how to like run your own shader inside a plugin, which is actually quite really useful for many different type of scenario. Well, you have plenty of cases where you will want to run something internally on just black box. Like, for example, if you start to need to do like some form of color space conversions, for example, you don't really want to say, I need a texture FX around, or you need this around. It's kind of nice to have this node that does all that's needed. So we're gonna do just a simple texture FX actually. So we're just gonna do a simple blend mode, and what we'll do is we'll do some form of blend aggregate. Let's call it something that way. So that one will take a little more time to do because there's a bit more things involved and I'm doing it from scratch. So actually I'll create it in a new project. So we use our template again here. And template, so notes, Blender. So what we're gonna do is we're gonna kinda do this blend node texture FX again, but it's a bit like we're gonna do some form of blend spectral, if I can call it like that. I will not put the bin size. If you can keep it as exercise for the reader, or if we have time, maybe we'll add it. Let's see. So the first thing we need in case we need effects is we need small effects folder, and we need well, we need our nodes folder as usual. We'll node. So here, but not class. We need to add a new file, new item. Well, there's not really any good default for that, so I'll just do a class actually that will do. Blender.fx, and get rid of all this, of course. And what we need is we'll want to put it inside our DLL, so we create it as embedded resource. So what we'll do also something a little. So it's more or less the same as our usual blend shader. So we need a sampler state. Sampler. I'll call it sampler. Sampler. Okay, so we have two, well, really different ways. So either we're gonna rewrite it, or I just grab the code from one of the TFX. So let's say, okay, let's grab the TFX version. I'm not gonna reinvent. Or I'll grab my own version, which also works. And for the question, no, because I just renamed it as fx anyway, and there's no more compile. So as long as you change the extension, it's not interpreted as C# code anymore. And the build action is embedded resource anyway, so that means that we'll never try to even compile it. Okay, so we're gonna grab our blend functions here. Let's grab this TFX instead, that will be a bit easier. Okay, so now we have our little blender here. We don't need that put texture. Second texture. So now we have our standard, more or less, technique fx file. And we're gonna create a simple, well, we're gonna actually just first wrap the blender as a plugin. So blend node. Okay. And now we need an input texture input. Let's see this. Maybe. Oops. Yeah, fine. And input texture input to protected spread texture 2D texture, and we obviously need an output. And in our case, actually, I will say I don't want to use the size of texture input or texture input 2. I want to use a fixed size all the time, just because we want to size. Let's say default values. New. Let's say 640 by 480, but we can put a bit more. Okay, So now we don't really want to make it spreadable, because I'll explain the reason later. So the first thing is here we need to initialize oops, and it's sorry a little bit too fast. And of course, since we said we want to, we need some obvious alpha. And we'll just set it nicely. No, stop. Okay, so we'll just set it nicely for the user interface to be between 0 and 1. So let's go now. We still have a little to do. First we actually will probably want a pin here. Because we'll want to know if those elements are connected. So now we need to update, so we need to mix the texture. So the first thing we're gonna do actually, we're gonna check, we need to check if those are connected or not, because if they are not connected, so we can do a bit more check with C# that are a bit more easier to do fine-tune compared to if you do that with patching. So first thing we're gonna check, so if texture is not, if not connected, we're gonna just say this dot, we can quite quickly get the edge cases here. So we have the case where nothing is connected, so we need to decide what to do. So in that case, we'll just say context dot default textures dot white. And return. So now if we have texture 1 but not texture 2, we're just gonna say texture output 0 equals texture 2, texture 1, sorry. And return again. And now if texture now we check the obvious reversed version. Okay, so now we have this edge case sorted. So we need first, now we have the edge case of return the other one if one is not connected. We have the destroy, which does nothing for now because we only return the other operations. And now we need to finally also grab this shader. So what we need to do is we need to get that from our resource. So it's a bit the way special in the way C# does. So private DX11 effect, and from resource. So assembly is system. We want to use this assembly, so it's reflection.assembly.get executing assembly, and pass is, so the root namespace in case of embedded resources is the one which is here, default namespace. So you need to get this, and just need to double check something here. Yes, that will be fine. Just want to check there's no input there. We should have no target side here as far as I know. So now we have our namespace, so .blender.effects .blender.fx. Okay, I will simplify it a little for the time being. So now we need to create our instance. So if instance so now we have our shader instance. Okay, we'll just do alpha blend for now, which should be the first technique. And we need a render target. So we'll use a temporary one in our case. We don't want to use an owned version. So no, in our case, dot unlock. So basically what we do now is, like, if we have a new frame, we just say our current resource from last frame, we just free it, basically, simply. So we need to keep it for the frame. Now we need to start the blending, so we need to acquire one of this new resource. So that's size 0, and let's use a vector 2 here. And in that case, we also need it as int equal to dot x, and it's int here. So format, we'll just use a standard format, which is RGBAU now. We don't need mip maps, we will keep one level, so we can keep all the rest to default. So now we have our new resource entry, and we need to blend those two textures. So what we need to do is, first we have, I will organize the layout a bit differently, like this. We can hide that for now. So what we need to do now is we first need to assign, because there's no vertex shader assigned here, so we need to apply that. So vertex.primitive apply full tree vs, and we need to push this resource to, because it's not assigned as a target for the moment, we just grabbed one, so we need to push it when the target stack dot push and resource entry dot element. We obviously need to pop it at the end. So when you push a render target, what the pipeline does, it will assign it, but it will also set up a viewport for you, so you don't have to worry about that. Otherwise, you always have to set up viewport on some states. This one does this a bit automatically for you, which is pretty useful. And now we only, you need to assign those variables. So instance dot set by semantic, and we have our input texture, which will be texture 1. And second texture, so texture 2. So we need to attach our textures now, and we don't need target size. I don't think we need, and we need to set the opacity though. So set will set up also. In that case, there's no semantics, so we can set by name. And alpha. So now we're almost done, but we need to apply these changes. So it's apply pass. Which is 0. And from there, we need to draw our triangles. So we use a full screen triangle, so that means we use 3 vertices. So you can either do it in the context.primitives.draw full screen triangle .draw, or if you prefer, you can also do it directly context.current context.draw, and it's 3, 0, which is exactly the same. So we'll keep it on this one for now. And we're gonna test it, of course. We start our Visual Studio. We will probably want to double check, so here, so we'll put breakpoint just to be sure. So, and okay, it's not gonna work, sorry, because we need to put some info. Info, name equal Blender, category equals DX11 version texture. Okay, and now we can start again. Okay, we're gonna and I guess Visual Studio mess up that again. Hmm. Yeah, it did not build the solution properly just before. and it doesn't like my Blender. Ah, okay. Yes, of course. On library. There we go. So, okay, and I'll add two textures. Let's go on our usual. Yeah, our famous desert picture, and let's go our famous koala picture, and I will need another one. Well, let's just grab a hello, that will do. Okay, so first descent, and voila. Okay, so first one is working, second one is not. Yeah, we know that compiles. It's a little problem. Okay, one also useful thing you should. How is it using that? Okay, let's instance. Ah, yes, of course. Ah, there we go. So now we have a stupid blend shader, which, as you would expect, and I'm sure many people will say, well, actually, you could just have typed blend.tfx and be done with it. But obviously now we're gonna do something a bit more fun with that. So we're gonna do some kind of spectral version. So we keep the same shader, we don't need to change it. No. Then spectral node. Spectral. So now the only big difference is we don't gonna use that way of organizing our texture. We're gonna do it by spread. So if one case, if it's not connected, we return a white texture. And that's about it here. So now what we're gonna do instead, we need a list of intermediate target. We're gonna do it with ping pong. So now we need two resources here. I mean, we can optimize that, of course, a little bit later. Let's call it read. Work first equals true. So if first else, and we need to iterate. So we don't have access to spread max in update also, so we need to keep a track of it. And max. Or we can do it on the slice count of texture also, so it's not very important. So first thing we need to do, we need to iterate and it's gonna be -1 also. So if this texture1.slice count equal 1, we just return so if we have only one texture, we don't obviously need to do any form of blending. So now we have our read-write resource. So first thing we now need to do, we need to change a bit our logic. So we need to push dot render target stack dot push, and we need to push resource write dot element. At the end of the iteration, we always need to pop. So now we also need to get our, again, drawing here and our apply pass here. Only little difference is we can apply the full screen triangle only once. We don't need to do that several times here. So now we have a little bit of difference. It's like our opacity will be alpha I, and so our input so on the first frame, like input texture will be texture 0, and second texture is always I plus 1. And now if we are not on first frame, like our input texture is now the result of the previous iteration, so it's gonna be what we have in resource read. And now, of course, we have a little thing, which is we need to swap our resource read or resource write. So we need to do the infamous swap. and we need to clean up that a little tad. Yeah, good point. So now resource read. We need to keep a track of it. So resource entry or resource read, and resource write, we can unlock it. So if we go now, change our example again, blend shader spectral. So now the difference is we need to cons here. Cons texture. And let's do another preview here. So it's obviously doing exactly the same as before, with a little difference is now we have a spectral version. So if I take another cons, and copy that blender, and we need 2 alpha and preview. So we start to bring our koala in, and we need to start to bring. So we have a little spectral blender. And now obviously we'll try to add the techniques around, so we can add different blend modes. So we need to do something horrible, I know, called enum mode. So there's 2 different ways to do that, and I'm gonna do the one lazy way. I'm gonna reconstruct blend mode enum here. Okay, that's enough there. I don't think I use any of the other one ever anyway, so that will do. I'll keep the fact of adding the other one as very complex exercise for the reader. Mode. And protect it. And we also need to do instant.select technique mode I to string. So now we also have spreadable technique, which you should be able to verify right now. So now we have our little spectral blender, which has also the spreadable techniques. So what we're gonna add now, again, we're gonna add actually we're gonna do another version which has some real bin size. So yeah, it's also to explain like this type of for example, this type of nodes are pretty difficult to do with texture effects actually, because obviously you don't know how many elements you have here. If I just add a new picture, I just grab something random from the drive. What's that? Perfect. Bunch of. Okay, I just add some random pictures again. Okay, so I'll add this one. Whichever, and so now you can obviously. So yeah, it becomes really straightforward to add new textures to your Blender. And you can also notice by doing it by plugin, it's also easy to use all these ping pong techniques. So you actually only use 2 resources instead of 1, and you have unlimited blending. So it's a bit easier by plugin. It's always quite easier to do a bit more fine-tuned resource management compared to doing that by patching. Actually, it's almost impossible to do that in its current state without plugin. So you could also use different ways for that, but let's say that's another topic. So yeah, being able to use your own shader is pretty useful as soon as you need to do a bit of iterative techniques, or if you need to handle these spreads around and have a bit of hungry resource management. And it's not really even really bad. Like if you look around, you just have, it's not so much code plus one shader, and you can do some pretty neat stuff if you have different plugins. So you can also do if I check again. Yeah, by the way, if you start to play with resource pool, one thing I really recommend that I did not do here, and I should really have, is you should use this info DX11, put a toggle here, it will cost you a bit of strength, and always refresh on. You should always really check this render target count here. Basically it tells you a bit how the pool is occupied. So it's kinda super important to be able to check that around. It's really important to check that around because if you miss some unlock, you will see this number will really grow drastically, and you will be out of VRAM in no time. So you'll have some pretty serious issue. So it's pretty recommended to do that type of thing. So now let's see if, how long it's been. It's been 2 hours and a half. So shall I do a small? Okay, so let's do a last quick example. I'm not too sure what though. It's actually a good question. Okay, yeah, I know. Okay, so last example, I'm gonna do something again a little different. I didn't do it for a while, so I have to kinda remember that. Okay, we're gonna do something a bit silly, but which shows also a bit something different. Yeah, we're gonna build a few other buffer. I will show a bit something a bit more internal. Actually, I think that will do for finishing that. So, new project again. And so we're gonna create a few buffer nodes again, like some structured buffer. But we okay, so let's start with a few questions. So we're gonna create some buffers. So okay, let me reply. Oops. So if we look like on resources, like we have these dynamic buffers around. So well, the cool thing is obviously with dynamic we can update them right away. The thing is, well, sometimes we want to use dynamic buffer like just a bunch of random values, and that's about it. And so we never want to change it. So like dynamic buffers are kind of cool actually for something we want to change more or less every frame, but they're actually not that cool for something like which we want to build once and don't change. So we generally want to change it once. That's it. So we're gonna create our new little resource type. So actually, if I show you the code of what's here, resources, buffers, structured buffer. Oops, that's not the right one. Structured buffer, resource, buffers, structured. No, it's not working that way, never mind. Opening that way. Okay. So when you check dynamic structured buffer, we can see we always create this description here, which use shader resource. We allow write access on our CPU. We say it's a structured buffer. We have a size in byte, structure stride, and our usage is set as dynamic, which means when we want to update that resource, we call this write data. So we actually map the resource, which, well, it's a bit tricky to explain, but basically we should just say, no, we need to upload data from our CPU to this resource. And we write our data and we unmap to say, no, we finished writing. So we can tell our graphics card that it's usable again. So there's a few quirks about it, which I'm not gonna go in detail about, but that's about how it works. So little thing with dynamics, they're kind of fast to write, but they're a little bit slower to read. So what we're gonna do is we're gonna do another version, which is some immutable buffer. So the immutable buffer ID is we create it once, the resource, and then, but we can't change it. So we have to provide the initial data. So let's start that. So we'll need simdx, we need to use this equals simdx.directory.buffer, and using and we're gonna make it generic, and we need to make sure to tell it's readable buffer. Okay, so it's, as you can see, asking for a few things. So we need a buffer, so get private set, which is pretty much all what we want. Get private set okay, we can actually and so now we have our initial thing, but now we said we need to, so it's considered as immutable, which basically means we should provide initial data to it, and we'll provide it in the constructor. And we need our device, and we need an array of initial data. So now we need to set up our properties, so size, no, we don't need size, sorry. So this dot element count equal initial dot length, this dot stride equal. So now we need to get the size of our element, so that's the size of one element. And now we need to create our new description. So in that case, we'll have a few changes. So bind flag is basically what you can assign your resource to. So since obviously depths in render target unordered are right on our resource is immutable, we only want shader resource, so we want to be able to read from it, that's it. CPU access flag, we don't want to be able to write to it, so we mark this as none. Option flags mean we still want a structured buffer. Size in bytes will be this dot element count multiplied by this dot stride. Structure byte stride is our stride again, and our usage is immutable. So now we need to, well, I'm not using sharpdx, so I can't use their util for Marshall copy. So we have to do it in a little different way, which is not that difficult. So we need to grab a handler on our initial data, alloc initial data, and we want to pin our data for a little while. So we need to block our initial data to be moved by the garbage collector by the time we're uploading it. So we need to pin it for a little while. Now we can create our slimdx data stream, new data stream, and we need to take the address of our element, and our size is this dot element count dot multiplied by this dot stride, and we don't really care about that. Let's keep we can't write actually. Okay. And now we can upload our buffer. So this dot buffer equals new buffer device bd, and we need to provide our initial data, which is in our data stream. So now we created our buffer, and we need to create the shader view for it, which is new shader resource view device dev, oops, and this is dot buffer, and obviously don't forget to free your pinned object. So now we have a buffer that we can only write to once, usually when we create it. That's it. It has also some advantages over some other ones. Is when you create immutable, they are also thread-free, which means you can upload them in background with no issue. So you don't have to care about synchronization like you would eventually have to do with dynamic and unmap. In that case, you kind of have a bit more safety in that thread aspect, which is kind of cool. And now we're just gonna say, let's create a random buffer. So okay, we'll just use only 2 elements. So just use the seed. we need count also. Let's say we have 32. And of course we need our buffer now. Okay, so now we do the same. This dot output and okay, so now I just leave the destroy, run and the dispose, but they are more or less the same as the previous one. Now we need to update, so if and actually we don't even need that. So we create our new array and we start to and our seed is at 2. So we created our array now, and we just actually need to So here we go. Now we have like a random buffer. So the big difference is this one is kinda immutable. So it has a little difference from the dynamic ones. Is basically you create a new one all the time. So like it should not be one where you use apply every time. It's quite common to use eventually. Well, I keep it as exercise for reader. To instead of having dynamic buffer node, you could use one with input as immutable instead, which takes a spread of data. So you have the source code for it in the GitHub repo for dynamic, and you'll have the source code for this one in another repo. So you could do a generic version of this immutable buffer node, which should not be ultimately too complicated. So regarding question about best practice for texture on video, yeah, it's really depending because you have a lot of cases. Basically, you like if you want to go through the basic one, you will create you will create a dynamic texture and you will map and write to it. So dynamic, when you do discard map, it's a bit yeah, the runtime does quite a bit of things for you. So you have two really way to do this. It's either you're gonna create this immutable texture, and when you receive a new frame, you copy to immutable, and then you have to discard the values when you don't need them anymore, which is one option. Or you can use the dynamic way. So there's a bit of things like which are a bit different with dynamic. I can show quickly, for example, like with something already existing that will make certainly more sense. So I'll just take a Kinect 2 texture, which is the one that makes the most sense. So idea here is I have a double buffer for in the CPU, but you don't really need double buffer in the GPU in DX11 because actually the pipeline will do that. We actually handle that for you in some ways. So basically, when you're gonna call your texture write data here, so if you check a dynamic texture 2D here, implementation, you have this write data where you provide this. You have quite a few write data actually. And I will need the pointer version, like that one, perfect. So when you're gonna upload a texture, like actually if like the pipeline does some things for you. So when you create this map with write discard here, before to copy the texture, what the pipeline gonna do, it's gonna check for you if this resource is in use or is gonna be in use. So that means when you use write discard, you can actually, the pipeline might actually allocate memory for you and actually deal with this queuing for you. So that's generally the easy way to do, let's call it that way. So, but you have two ways: you create immutable and manage the queues yourself, or you use write discard. That's the only two things for like anything which you receive in async fashion. That's two ways. I know you have a bit more advanced way you could eventually do nowadays, but they're a bit more tricky to explain in 5 minutes. And so I think that's kind of well, it's been almost 3 hours now, so I think we might want to put it to a close. So yeah, I will say thanks for listening, and what I'll do, if you have a question quickly on the chat, you can still, I'll stay a little bit on the Skype chat to reply to some question around. I will clean that stuff up a little bit, and I'll load that on some GitHub repo so you can play with it. So thanks for listening, and let me do this stopping thing properly. Thanks for listening.